Good afternoon, people. Today we have building construction, and we'll be looking at retaining walls. Now let's start. Retaining walls. The major functions of any retaining wall is to act as an earth retaining structure for the whole or part of its sides on one face and the other being exposed to the elements. Most small height retaining walls are built entirely of brick or a combination of brick facing and blockwork or mass concrete backing. To reduce hydrostatic pressure on the wall from groundwater, an adequate drainage system in form of weep holes should be used. So we should use weep holes to reduce the hydrostatic pressure. Now let's look at different categories of retaining walls, and we start with small height retaining walls. Retaining walls must be stable, and the usual rule of thumb for small height brick retaining wall is for the height to lie between 2 and 4 times the wall thickness. Stability can be checked by applying the mid-row-third rule. Here are the typical details for the mid-row-third rule. Here they are. These are the what we are calling the mid-row-third rule. Let's now look at the typical details of a brick retaining wall. As you can see here, the height is greater than 1 meter high. Retaining wall of dense clay, engineering brick said to English bond, is a drainage channel to drain away the water. You can see here this mass concrete, which is 900 millimeters wide. Yes, in the ratio of 1:4, 75 millimeters PVC. This water we calling the weep holes. These are the weep holes. 200 mm wide, 75 nominal distance to no fines granular backfilling. Yes, these are the typical details of small height retaining walls. Now let's go and look at medium height retaining walls. These are retaining walls up to 6 meters high. They are the ones which are being classified as medium height retaining walls and have a primary function of retaining soil at an angle in excess of the soil's natural angle of repose. Walls within this size range are designed to provide the necessary resistance by either their own mass or by principles of leverage. Let's now look at design. The actual design calculation are usually carried out by a structural engineer whose endeavors are to ensure that overturning does not occur, forward sliding of the wall does not occur, materials are used suitable and not overstressed, the subsoil is not overloaded, and finally, in clay, subsoil slip circle failure does not occur. Those are the functions, the roles of a structural engineer in designing a retaining wall. And now let's look at factors which the designer will have to take into account. 1. Nature and characteristics of the subsoils. Height of water table, the pressure. The presence of water can create hydrostatic pressure on rear face of the wall. It can also affect the bearing capacity of the subsoil. Together with its shear strength, reduce the frictional resistance between the undersides of the foundation and the subsoil, and can also reduce the passive pressure in front of the toe of the wall. Now you have to consider type of the wall and the materials to be used for the wall. And let's now look at retaining walls terminologies. Here we have a supercharge, and you can see here this upper ground level here. Yeah, this is the front face. You have the sloping or battered face. You can see the rear face, straight or vertical face. Stem, this is the stem. Here we have the stem. As you can see here, this is the angle of ripples. What we are talking about, the angle of ripples, this one here. Here is the heel, base foundation. You can see at the toe. What we are talking about, drainage or ripples, it is. Those are the various types, parts and terminologies of a retaining wall. Now let's look at earth pressures. These can take one in two forms, namely one is active earth pressures. These are those pressures which tend to move the wall at all times and consist of the weight of the earth retained plus hydrostatic pressure. The latter can be reduced by including a subsoil drainage system behind and through the wall. Now let's go to active earth pressures. These are reactions of unequal and opposite forces that to any imposed pressure, thus giving stability by resisting movement. These are the two types of pressures that can act on the faces of a retaining wall. Let's now look at the typical examples of those pressures. You can see here this ground pressure, which is passive pressure. Is the one, is another one, passive earth pressure in front of the retaining wall being exerted on the wall. You can see this also an active pressure behind the wall, wedge or retained earth plus hydrostatic pressure. As these are the, you can see if this force acts here, the wall we tend to move forwards. Yes, most of all acts downwards. These are the type of pressures that act on the faces of a retaining wall, and the retaining wall has to be designed to be able to resist them all. Now let's look at mass retaining walls. These walls rely mainly on their own mass to overcome the tendency of sliding forward. Mass retaining walls are not generally considered to be economic over a height of 1.8 meters. When constructed of brick or concrete and 1 meter high in the case of natural stonework. Any mass retaining wall can be faced with other materials, but generally any applied facing will not increase the strength of the wall and is therefore only used for aesthetic reasons. Let's now look at cantilever retaining walls. These are constructed of reinforced concrete with an economic height range of 1.2 meters to 6 meters high. They work on the principles of leverage, where the stem is designed as a cantilever fixed at base and the base is designed as a cantilever and fixed at the stem. Several formats are possible, and in most cases, a beam is placed below the base to increase the total passive resistance to sliding. Let's now look at typical details of cantilever retaining walls. As you can see, the top is 300 millimeters at the top. Here is the ground level. You can see concrete to be 1:2:4 with 20 millimeters aggregates with minimum cube crushing strength of 21 newtons per millimeter squared at 28 days. So the concrete should be allowed to cure for 28 days. Then you have welded fabric to control shrinkage cracks. You can see the 75 millimeters diameter whip holes at 1.8 center to center. You can see this ground level. Then you can see previous membrane of our nominal 25, now finds granular black filling. You can see the main bus. Yeah, they are here. The main bus, reinforcement bus at 300 centers to center is nominal diameter distribution bus. You can see the main bus are here also. And let's now look at the base and the toe. You can see the toe is made of 450 millimeters wide beam. You can see there's other reinforcement here, which is 450 millimeters, and the height is 4.2 meters. And those are the typical details of cantilever retaining walls. And thank you for your time.